morning on this frosty Sunday morning, and it is indeed -1 degree out there. A bit chilly. No snow yet. We're working on that. Okay, just another little update. I don't think this will be particularly long part, but I have replaced all the parts that need replacing. And let me just show you the usual suspects. Now, the selenium rectifier was replaced. All the other capacitors replaced. These bumblebees, which are bad actors, replaced. And the 4-point or 4-part electrolytic capacitor bank has physically been left in place, but electrically everything's been removed from the circuit. And what I've done is, because the selenium rectifier, which was mounted there, is no longer there, I had the room to now mount a tie strip across there and put in these, there's the 3 out of the 4 filter capacitors that were in the filter can. The 4th one is this little fella here, which is a filter for the filaments, so it doesn't need to be a particularly high voltage. Now, all these capacitors, the original ones are rated at 200 volts because as a half-wave rectifier from a 120, that was 120 volts, that was particularly enough for that. But basically, I've given up on stocking 150 or 200 volt electrolytic capacitors, just doubling my stock unnecessarily. So these ones are now rated at 450, and that's fine. In fact, that's built in a little extra padded safety. Okay, all the other capacitors that are needed to be replaced have been replaced. The ceramics generally are okay. The unit has been tested. It's working fine. And these capacitors have been replaced in here. But there's something I wanted to go through that I don't think I mentioned before, and people may not be aware of it. Now, if you're just watching this for entertainment, that's fine. But if you are a possible restorer or repairer, amateur, whatever, there's things you need to know about this particular receiver. It's basically an all-American 5 is really what it is in design. In other words, it's a transformerless chassis, and that puts you at certain risks. Now, some old AC/DC, All-American 5 or All-American 6 radios actually used the chassis as the common. Well, the problem with that, when these were built and you did not have polarized power cords, depending on which way you plugged it in to the wall socket, you could either be putting the chassis at neutral, which is desirable, or unfortunately you could put the chassis at a full 120 volts. And if you did that, and it's random, there was no way of knowing otherwise, and you touch this surface and you touch the ground, you would get a nasty shock and could possibly be electrocuted. It is a dangerous situation that you need to be aware of. Now, in this particular model, what Zenith did was isolate the chassis, and I'll get to that in a minute, but all these blue-gray wires in there are actually the common, and they are in fact hooked up to one side of the AC plug. And that's fine. It isolates the chassis, but you can't leave the chassis floating. It will induce hum and oscillation, parasitic things, and all sorts of nasty stuff. So what they do is they put a capacitor which will capacitively couple the chassis to the common. And that's fine. If in that situation and the capacitor is in good condition, if you touch the chassis and that happens to be connected through a capacitor to the hot side and touch a ground, you will get a shock, but it won't likely kill you. It still could be a nasty little tingle that you get. So the problem that we have here, and let me move this out of the way and put this schematic back in here. Now, maybe I can just lower this down rather than zooming. So this is the capacitor that I've circled, and I did download this so I could deface it and put markings all over it and not destroy the original schematic or service bulletin that came with it. This capacitor originally was a bumblebee, and like any other paper capacitor, they will fail eventually. And when they fail, they can fail by short. In fact, that's quite common. Now, if you understand what a paper capacitor is, which this, even though this is plastic coated, it's paper inside, it is a length of foil, tin foil, aluminum foil, I'm not sure what, with a thin layer of paper and then another thin layer of foil. And then they're all rolled up. The two foils are not electrically connected, so one is attached to one end of the capacitor, one is attached to the other. Then they put some kind of paste, electrolyte, whatever in there, and all is fine for a while. But as the capacitor ages, the paper can break down, and therefore you can start having leakage, which is not liquid leakage, it's electrical leakage from one side to the other. So in this case, if this line happens to be inadvertently plugged in a way that makes this the high end, like 120 volts, and you have electrical leakage to the chassis, you now raise the risk for a serious shock and possible electrocution. If they fail completely and short right through that paper so that each foil is actually physically touching and is electrically connected, you have the same thing as sticking your finger in a light socket and touching a ground. You will be electrocuted. This is not acceptable. So what has happened is there's been a design of a capacitor, and this is one example. What is it? X1Y2, I think, is the designation. And these can be put across the line or from one side of the line to the chassis. And in this case, the design of these are designed to fail open. They will not short. And in that case, you will never run the risk of a situation happening where you expose yourself to electrocution. That's one style. This is another style. They're both the same kind of design. All right? So X means they go across the line. And this is also a problem. This capacitor was also a bumblebee. And even if it wasn't, any paper capacitor that I had already explained will run the risk as it ages to become a short. Well, you don't need, there's one side of the AC plug right there, and there's the other side, and this capacitor's right across it. So if it starts to short, then you can be blowing fuses, or this can explode right in your face, actually, and it's not a good situation. So this gets placed with an X style, which means X across the line. There's one lead. Eliminate looking at this. This is just a jumper. Basically, without that jumper in, there goes in to the anode of the rectifier, and then this goes to the so-called common on this side. So those capacitors did get replaced. If you're working on something like this or any kind of an AC/DC or All-American 5 that does not have a transformer, then you need to pay attention to replace these. Do not let them go unreplaced, no matter what you may want to do. Okay? So that lecture's over. I just want to make it perfectly clear that these can be a danger to work on. The other thing I wanted to mention is those capacitors that I put in and replaced electrically that capacitor pack. There's the representation. The dotted lines around there show that there are actually 4 individual electrolytic capacitors. The values are stated there, and they're indicated by these markings, either semicircle, triangular, or square, or nothing, to show that that's what the lugs coming out of the capacitor are. And there'll also be the common, where they're all connected, and that will come out to the actual mounting tabs. So when you see these things with cardboards around them, it means that the common, which would be connected to the case of it, an aluminum can, cannot be touched because it's a shock hazard. So they put cardboard around it and isolate it on a phenolic mounting tab. But those are the ones there. So I replaced them all with those individual ones that I showed there. Okay, so the unit works. I'm still having problems with the switch contacts, and I've used various contact cleaner on it. And, you know, this unit is 75 years old, roughly, and it's got a lot of corrosion. And I can't get in there with anything to clean too much because there are coils directly attached to the switch contacts, and if I make an inappropriate move on it, then I break one of these leads on. They're very fine wires, and they are represented by these coils: 1, 2, 3, 4, 5, 6, 7. That's the oscillator coils, and these ones here are the converter, input to the converter. 1, 2, 3, 4, 5, 6, and then the RF, which are these. A lot of them are mounted directly on the back of that, so you've got to be extremely careful. Something else I didn't go into too much is the, what have I got to point with? The tuning capacitor is 3 gang, and that almost always means you've got tuned radio frequency, and then you've got your normal converter tuning, and then you've got your oscillator. And in the schematic, it's represented by these 3 capacitors with the pointer on them, and then they're connected together with the dotted lines, which means they're physically connected together. And in this case, that makes the unit more sensitive by having a tuned RF amplifier, an extra stage of amplification, even before it gets to the conversion section in there. And I guess that's it. I cannot show it in operation right now because it's just a little past 11 a.m. and reception during the day is pretty bad. There's lots of noise, and I tried it last night or the night before when things were quiet in the house and most of the dimmers were turned off, and I managed to pick up a fair number of stations, and so I'll show that. I'll come back down here and do a final wrap on the chassis itself at that time, sometime in the evening. The case, well, I'm going to clean that up. I won't do that on camera, but I'm not sure exactly how well it will come up with some cleaning. If it's really bad, maybe next year I'll consider reskinning it with some vinyl fake leather or real leather. I'm not sure whether I want to invest that kind of money in it. So I'll attend to that in the spring when I can get down into my woodworking shop again. So I guess that's it. I think, and I hope I've covered everything of importance. And once again, thank you very much for watching, and we'll see you soon with the testing of the receiver in the next couple of days. So take care.